Good day, students. I hope you're all doing well. Today we're going to start with a new section of chapter 5. It's chapter 4, it's section 4. Uh, Although we haven't studied section 3 yet, but section 3 is talking about substitution method in definite integration and area between curves. But I thought that it would be better for you and for your understanding to explain section 4 of chapter 5 and then move back to section 3 of chapter 5. It would be easier for you to understand section 3 if you have studied section 4. Okay, so I'm starting with section 4 of chapter 5. It is about substitution method. What is substitution method and what is it used for? In general, in the previous lectures, we studied integration. We studied the integrations of type, the rules of integration, I mean. Okay, we studied integration. The rules of integration were like integration of k dx. If you have got a constant, that will be x, k multiplied to x plus c. That was for indefinite integration. What is indefinite integration? We know that it is the integration that doesn't have a bound. We studied integration of x to the power of n dx. If it is a power, that's equal to x to the power of n plus 1 over n plus 1 plus c. We have got a condition here: n must not equal to -1 because the denominator makes it 0 and undefined, and so on. For the other integration rules, we had integration of sine, integration of cosine, and so on. Okay, but these were the simple cases. Okay, we also studied the properties of integration. For example, if we had integration of f plus g or f minus g d of x, that would equal to what? Integration of f dx plus or minus, depending on this one, integration of g dx. Okay, what does that mean? That means integration is distributed over the addition and subtraction. Okay, um, those were simple stuff. How about if you have got something more complicated? If you have got, instead of x to the power of n, if you have got, for example, 2x plus 5 all to the power of n, how can we deal with those kinds of integrations? We will use substitution method, okay, to solve such kinds of examples. I will write the steps for you in general and very briefly, not as written in the course material. Okay, so in substitution method, what is the first thing that you have to do? You have to choose a substitution. Okay, what does that mean, choose a substitution? When the integration is given to you and you see something is complicated, you will have a let. Okay, you let u or any other variable, but in general u is used in here. U is equal to something. That something is the complicated thing in the integration that is given to you. Okay, uh, then what do we have to find? When you're letting u is equal to something, you have to directly find the derivative of that u. Okay, find du. Okay, that means find the derivative of this one. That's very important. Students always forget about this du, but this du is important because it is the key point for transforming the integration from x to u function. Okay, then when you're finding du, you are transforming the integration, okay, from fx dx into a function of u du. What does that mean? The integration that is given to you is in terms of x. Let's say it is in terms of x. It's something complicated for you. What are you doing? You're changing the x into u terms, u du terms. So the function later, you will see in the examples, will be all transformed from x dx to a new function that is that contains u du. Okay, then what do? We will solve integration of gu du. We will solve the new integration, the transformed integration. The transformed integration is still the basic information. The transformed integration is still the basic integration that was given to us, but we have done some changes to make it simpler for solving. Okay, we are doing that substitution to make it solvable and easy to look. Okay, so we are solving this gu. When you're solving that gu, you will get a solution in terms of u. Then you are transforming again, okay, gu into something of f of x. Okay, with the substitution that you have done, you are transforming the result that you get from part 4 into something f of x as it is required from in the question. Let's do the first example. That's the general idea for transformation, for substitution method. I haven't written this in a mathematical way, but in general, giving the idea of substitution method. Okay, the first example that we have got, it says find the integral. Okay, integration of x to the power of 3 plus x to the power of 5. Okay, then next to it 3x squared plus 1 dx is given to you. Okay, this one is given to us and it's required from us to solve it. If you remember previously, what did we have? That's just for remembering. If I had x to the power of 5 dx, how would I solve this one? Since it's x to the power of 5, so we are increasing the power by 1 over the power plus c. Look, this one is something very simple, x to the power of 5. But here, what do you have? You have got a bunch of stuff to the power of 5. Okay, so that's the thing that has made the integration complicated. So I will let u, okay, I will let u equal to what? That complicated thing that has made a problem for me in the integration that I have got. So I will say x to the power of 3 plus x. That is the let that we are doing, and that let will make our integration simpler. Then what do we have to find? We have to find the derivative of that u. So what is the derivative of that u? If I take the derivative of this one, I do the derivative of this side with respect to u, so I'm writing du, and the derivative of this side is equal to what? Is equal to 3x squared plus 1 all. I have taken the derivative of this side with respect to x, so that is dx. Okay, look, the derivative of this side with respect to u and the derivative of this side I took with respect to x. That's why I'm writing dx right next to it. Step 3, it says transform the integration from x dx into u du. Okay, why did we do those steps, this let and this one? So that we are changing that complicated thing to something simpler, so that we can solve it the way that is solved here simply. Okay, so that integration is equal to what? This is x to the power of 3 plus x, x to the power of 3 plus x. What have we set for? We have set u for this thing. So that will be u to the power of 5. Instead of that thing, that will be u to the power of 5. Look at here, what is remaining here? Because we have to change every x in that integration into u and du. There must be no x remained in that new integration, because if there is x remained in here, we cannot solve it. Okay, you cannot have two variables inside this simple integration. Okay, so we transformed this one into terms of u. We are remained with that part, 3x squared plus 1 dx. This part is remained. That's the same thing as this derivative of the substitution we have made. We always need this step and that step for transforming the integration. So that bit, I have to change it to something of u. That bit is here. That bit is equal to what? Is equal to simply du. Okay? So we transform the integration from x dx to u du. If you look at this one, it's the same thing as that. Very simple to solve. So that's equal to u to the power of 6 over 6 plus c. Okay, look, we transformed the integration. We solved the integration. And now this one becomes g of u. Then we transform g of u into f of, we have to transform g of u into f of x. Look, the result is in u terms, but the question that I have got is given in x terms, so I have to have the result in x terms. We're simply changing that u back to the x's that we had. U is equal to what? Is equal to x to the power of 3 plus x, all to the power of 6 over 6 plus c, and that is the required result. Okay, so we solved that integration and the result is equal to this one. But how did we solve it? Using transformation, using substitution method. We transformed by way of substitution an integration like this one into u terms, and we solved it easily. We're moving to another section, another example. Okay, we have got example 2. It's again saying find integration of 2x plus 1 dx. Okay, how do we solve this one? Previously, let us do it the simple way. We had this integration of, for example, root of x dx. That's the simple writing of this integration. How were we solving this integration? We were solving it like that, first changing the root into a power, and I know that if I have got a power, that will be increased by 1, okay, all plus c. Now I'm changing this one, that's equal to what? X to the power of 3 over 2 over 3 over 2 plus c. Rearrange this one all, you will get the simplified result. Now, instead of that x under the square root, what do I have? I have got something complicated to the under the square root. So I'm letting that complicated thing into u, okay? So let u is equal to 2x plus 1. Directly after finding u, after letting u, what do we have to find? We have to find the derivative of this one. What is the derivative equal to? That's equal to 2. But we have taken the derivative of this side with respect to x, so I'm writing a dx right next to it. Okay? Now, we have to transform that integration into u terms. I have it in x terms, it's complicated. We had substitution method, we're changing that integration to u du. Okay, now I have got the root as it is, I'm not changing anything with that one, but I have changed the complicated thing into what? Into u, so that will be u under the square root. What has remained in here? Dx is remained here. If I look into the transformation place, I have got dx here, okay, but I have got 2 that's extra right next to it, so I'm simply dividing both sides by 2. What will I get from here? I will get 1 over 2 du is equal to dx. Why did I do like that? Because I need dx alone here, so I need dx alone so that I see what is it equal to do this transformation. So dx is equal to what? I got this information and I used that information to get dx, to transform dx. That's equal to 1 over 2 du. Okay, so that one is equal to what? That's equal to 1 over 2 integration of u to the power of 1 over 2. Look at this u under the square root, it's the same thing as this one, but we have got instead of x, u. Okay, that is du. So how do you solve this one? 1 over 2 u to the power of 1 over 2 plus 1, the same thing that we did for the x, because it is the same integration. Now that's equal to what? 1 over 2 u to the power of 3 over 2 over 3 over 2 plus c. Rearranging that one, it will be 1 over 2 multiplied to 2 over 3, because this one is in the denominator. I will make it up and it will be 2 over 3 multiplied to u to the power of 3 under the square root, because this one is changing to that. Now the solution that I have got is in terms of u. I have to change it back to x terms because it's required from us to find it the integration of that x stuff, not u. Okay, so we solved it in u for simplification. Then we are changing the u back to its normal form. That will be what? Instead of u, it is 2x plus 1 to the power of 3 all plus c. Okay, I think it is easy. Now we are having another example. Example 3, evaluate, find, integrate, all gives you the same meaning. Secant square of 5t plus 1 multiplied to 5 dt. Okay, let's go to the simple form of this integration. We have studied that integration of secant squared x dx is equal to what? Is equal to tan x plus c. Okay, secant squared integration is equal to tan x. What do I have here? Secant squared of x. But what do I have here in the question? I have a secant square of 5t plus 1. So instead of that simple x, I have got something here complicated. So I'm letting that complicated thing and substituting it as u. Okay, so that is 5t plus 1. We said after this one, we are directly taking the derivative of this. So that's equal to 5 dt. Now, since we have got u and du, we are changing the integration in terms, changing it from t terms into u terms to make it simpler. So that integration is equal to secant square. I haven't changed anything with the secant square, but instead of 5t plus 1, I have got u, okay? And instead of 5 dt, I have got 5 dt is equal to what? Is equal to du, okay? Secant squared of x is equal to what? Here you have got secant square of u. That's equal to tan of u plus c. Instead of x, I'm writing u because here it is given in terms of u. Now, if you look at this one, the solution is in terms of u. I have to change it back to t because it is given to me in terms of t. So u is equal to what? Is equal to 5t plus 1. All plus c will be the result for the integration. You have got example 4. I will skip example 4 for you. Okay, I will leave it for you because it's easy. It is just cosine of 7 theta plus 3. It's easy. You can solve it yourself. Example 4, integration of cosine of 7 theta plus 3 d theta. You're letting this part, okay, as u, because this is the angle. We are setting the angle into u. Then you are finding du, then you are substituting it. It is already solved in the course material and it is easy, the same steps that we have done in example 3. So I will leave it for you, okay? Do it yourself. Okay, now we are moving to another example. It is also easy. We have got example 4, example 5, I mean. It is again asking for finding the integration of x squared sine of x to the power of 3 dx. What do we have here? We have got here is making a problem for us. So we are letting u that's equal to x to the power of 3. Then you're finding du that's equal to 3x squared dx. Then we are changing that integration, okay? That's equal to what? It is equal to sine of x to the power of 3 is equal to sine of u, because we have set for x to the power of 3u. What is remained here? X squared dx is remained to be changed. So we have got x squared dx here, and we are dividing both sides by 3. So that will be 1 over 3 du is equal to x squared dx. So x squared dx is equal to what? 1 over 3 du. So that's a simple integration, sine of u du. What is sine of u du? Sine is equal to minus cosine, okay? That's plus c. Then we have to change that u back to its normal one, I mean back to the x terms. So that will be minus 1 over 3 cosine of x to the power of 3 plus c. Okay, that was also easy. Now we are moving to example 6. Again, evaluate or find or integrate integration of x, 2x plus 1 all dx. How can we solve this one? That's also an easy example. Here, what do we have? We have got under the square root is something complicated. So I'm letting u, that's equal to 2x plus 1. Then we said after the derivative, we are directly, after the u, we are finding the derivative directly. And then the integration is equal to what? That integration is equal to, I'm putting this one first, that will be u under the square root. Okay, what is remained here? X dx is remained here. I will extract x from that substitution that we have got. So this one changes to what? I'm taking the 1 to the other side, so that will be u minus 1. That's equal to 2x. Okay, then I need x alone to be transformed. So I will say u minus 1 over 2 is equal to x. So instead of that x, what shall I write? I have to write u minus 1 over 2. Okay, and instead of that dx, here I have got dx. What will I get from here? I will get 1 over 2 du is equal to dx. Look, we did two more steps for solving this one, for transforming this integration. So that one is equal to 1 over 2 du. If you look at this one, 2 multiplied to 2, that's equal to 4. I will take 1 over 4 out of the integration. Okay, that is u. Okay, let me write one more step. U to the power of 1 over 2 u minus 1 all du. Now this one is equal to what? I'm multiplying this one to inside. Okay, that would be integrate 1 over 4 integration of u multiplied to u to the power of 1 over 2 multiplied to u to the power of 1. The powers will add, so that will be u to the power of 3 over 2 minus u to the power of 1 over 2 multiplied to minus 1. That's equal to u to the power of 1 over 2, and that's all du. Now solve this one, you will get the required result. It is easy. That will be u to the power of 5 over 2, because you are equalizing the denominators and increasing the power by 1. That will be u to the power of 3 over 2. Then you are changing the u's back to 2x plus 1, and you will get the required result. Okay, these ones are simple and just algebraic operations. That's why I'm leaving it for you. I know that you're good in those simple stuff. Okay, let's see if you've got other examples. We've got example 8, but before we move to example 8, we have got integrals. The topic is, let me write the topic, integrals of sine squared of x and cosine squared of x. Here we were evaluating integration of sine, that's equal to minus cosine. Integration of cosine is equal to sine. Okay, we know these ones and they are easy. You're already familiar with those. But how about if you have got sine squared or cosine squared? Okay, we are not saying, of course, integration of sine squared is equal to minus cosine squared. We definitely do not have anything like that. But we are using trigonometric identities that we have studied. I think it was in chapter 3 or 2 about trigonometric functions, how to transform that sine squared into something simpler. Okay, so we have got example 8, or let me write for you the formulas for changing sine squared and cosine squared. We had the identity that sine squared of x is equal to 1 minus cosine of 2x over 2. Okay, and we are, of course, we are not using sine squared is equal to 1 minus cosine squared of x, because we will have cosine squared in it and it will make a problem for us. We are using this one to simplify it and make it cosine to the power of 1. Okay, and we have got cosine, sorry for that, cosine squared of x is equal to, again the same thing, 1 over 2, 1 plus cosine of 2x. Of course, you can also write this one as 1 over 2 multiplied to 1 minus cosine of x. We said sine and cosine, look, they have got the same rules. They differ only with the sign that is written in here. Sine is salib, cosine is co. Okay, so in example 8, what is given to us? It says find the integration of sine squared of x dx. Okay, look, the angle here is something simple. We do not need to use substitution method, but I have to change that sine squared into something simpler. Okay, so what is making it something simpler? This one is making it simple. So I will write that's equal to 1 over 2 integration of 1 minus cosine of 2x dx. Okay, that's the 1 over 2, because we can write this one as 1 over 2, 1 minus cosine of 2x. You know that. Okay, so I took 1 over 2 out, and what is remained inside here? This is remained here. So 1 over 2, what is the integration of 1? That's equal to x, minus, what is the integration of cosine of 2x? That's equal to 1 over 2, because we need to have the derivative of inside outside the bracket. That will need what here? I need 2 here. Okay, so to put that 2 here, I have to get 1 over 2 out of there. You know these rules. Okay, that's why I'm not explaining it more. So that will be sine of, cosine is the integration of this one is equal to sine of 2x plus c. Multiplying these two inside, you will get the required result. So when we have got sine squared, we are changing it to double angle formula, this angle formula, to make the sine and cosine simpler, and then solve it. We have got the other example is about cosine squared of x dx. You are doing the same procedure to make the cosine simpler. We are not using substitution method. Instead, we are using the substitution method. That would be 1 over 2 integration of 1 plus cosine of 2x all dx. That one is also easy to be solved. We know that that's equal to x, and the derivative of this one, the integration of this one, is plus 1 over 2 plus 1 over 2, where was it? Cosine becomes what? Becomes sine of 2x all plus c. Okay, and that is the required result for sine and cosine squared of x. That's all of section 4 of chapter 5. If you would understand this substitution method, we are using the substitution method for definite integration in this third section. It would be much more easier for you to understand it if you know this substitution method of indefinite integration. Okay, bye for now. I'll start the other section in another video.